Welcome everybody. Today we're going to do a tutorial on how to use a hierarchical instance static mesh to generate the spike ball that you're looking at here. So in this case, the center is just a sphere that we created a material to apply some distortion to it. I will show you how to do that, and then I'm going to show you how we dynamically generate all the spikes coming out of the ball, their size, their length, and the position that they're pointing, and then just a simple rotation. So this is kind of a combination tutorial. There's just a few items which are we're kind of sticking all together to come up with this effect. So that's it. Let's get going. The first thing I'm going to show you is I created a blueprint, and this is going to be our main actor that we were looking at earlier. So in this blueprint, I just called it Spike, and I added two things to it, to the default scene. The first thing that I added was a sphere, and this is just a static mesh component. And the second thing was I added a hierarchical instance static mesh. And this is what we're going to use to create these spikes. The very last thing is I added a rotating movement, and I just set some rotation rate values over here. So you can choose whatever you would like, as far as rotation. I did it just so that you could see it spinning around. So the big part of this is we're going to start with the event begin play. We're going to do a for loop, and we're going to iterate from 0 to a variable number of spikes. So I just created a variable called max, passed it into the last index. Then what we're going to do is we're going to create a random unit vector. This random unit vector, so you just right click and type random unit vector. This is going to generate exactly what it says, is a random unit vector. And this is already normalized, and I'm going to store that as the surface normal. So remember, we're going through each of the items here from max. So we're going to do this loop multiple times. Each time we're going to generate a random vector, and that vector, if we go back and look at our, it's going to generate, a pointer from the center outwards, and it's randomized. Okay, so that random vector I store. Then what I do is I take the sphere component, I get the bounds, which gives me the radius, and I multiply that by the surface normal of this point. That will get me from the center of the sphere out to the surface of the sphere, right? Then at that point, I take that value and I multiply it by the get actor location. So whatever the location of the actor is, I take that center point and I add it to there. That's going to get me out to where the surface of the sphere is. The next thing I do is I'm going to get a rotation from the surface normal. So make rotation from Z. That's calculating a rotation from the Z axis. So you can go look that up on your own. The next thing, before I get a little, I don't want to confuse you too much, but basically in the loop that we're doing, let me just scale this out a bit. In the loop, we're calculating a new normal. We're going to calculate some locations and a rotation. Then ultimately we're going to, on our hierarchical instance mesh here, right, we are going to add an instance. And so that's the key function that is going to be adding a new spike in that's sticking out, right? So what I do is I calculate a randomized radius. So it's actually the scale that I'm using here. So I set radius to some random value between 0.01 and 0.1. And you see down here, this is where I use that as the X and Y scale transform. And then to calculate the length of the spike, I just use another random floating range, do 0.3 to 1.5, and I add that instance. And note that this is adding an instance to the world space. There's another function called just add instance, and that's local space. So you want to use the world space one. So what happens is when we do begin play, you can ignore this up here. That's another way to do it, where you add a static mesh component. But begin play, we're going to loop through the number of spikes we have, get a random vector, calculate some offsets of where it should start and finish, and then ultimately we just add that instance in. Now on the instance itself, you specify the static mesh you're using. In this case, I'm using the basic shapes cylinder that comes with the engine, and I'm using a material that I created. For the static mesh of the center, I'm just using a material sphere, which comes from the game starter content, and another material instance. So let's go look at those instances of the material real quick, and I'll show you how I created those. The first one I'm going to do is the ball, or I called it ball, but this is the center portion of the spike ball. So in this case, I did set up parameters. So I have a color, base color. The material itself is just the default surface and opaque and default lit. So we have color, we have the metallic, roughness, and I'll adjust these so you can see how they behave later. Roughness goes from 0 to 1, 1 meaning it's completely rough, and 0 meaning it's smooth like a mirror. Metal is 0 to 1, 0 is non-metal, 1 is completely metal. And the only interesting thing here is the world position offset. So based off of the number of vertices in your mesh, you can get smoother or smoother deformations. But all I do is I take a noise material, and then I take the vertex normal world space. So this is for each vertex, I take the normal at that vertex in world space. Let me stop previewing this. There you go. So now I was previewing just the noise. But when you do that, you see here now that this has deformed our sphere. And the reason is the noise, which we were looking at earlier, the noise, let me preview this. So if I preview this, so you've got, your noise, and I turn the scale down real low, 0.005. So you get some segments of black and white. Well, if you multiply that by the vertex normal, then you're going to start getting some of the positions along the surface being pushed down, like pushed in, and then some are going to get pushed out. So white pushes out, black pushes down, and if I take that and multiply it by a factor, like a scale, so it's just a float, but you could call this like the strength of the deformation, and apply it to the world position offset, you see that all of a sudden it starts deforming your mesh, which is pretty cool, like that. All right, the next one we're going to look at, so we're going to go to the this is the spike material. So on our hierarchical instant static mesh, you provide a cylinder and a material. So the base material for this, it is translucent. So I just did surface translucent default lit. I set a color, which I converted to a parameter. And the opacity, the only interesting thing I do here is I use the fresnel function, and that gives you this nice outline where it's less opaque, or it's more opaque around the edges, and less opaque in the middle. So that's kind of how like glass reacts, right? And then I passed in a few parameters, the exponent in and the base reflection fraction in. So I set those up so we can adjust them. So if we go back to our, let's go back to our, this is our actor, but let's go look at these instances real quick. So here is our material instance I created for the ball. So here, right, you can adjust the, this is my strength parameter. So if I want to make it stronger, you can do this, or less deforming, right? This is just back to a ball, or you can just do a little bit. So I'll just do a little bit like that. And then I can change the metallic value. So remember, 1 is completely metallic. If I go down to like 0, then that's more like just a base material. So I don't know, I can go somewhere like 0.7. The last one is the roughness. So the closer you get to 0, it becomes extremely smooth. You can see the reflections very well. Or if you go up to 1, it's completely diffuse. So it's not reflecting anything. So again, I'm going to go somewhere down pretty low. I'd like that reflective thing. And I could also change the color if I chose to do so. So all you do is uncheck that, and we'll do like a light green. Okay, green seems to be the color of the day. The next one is we're going to go to the material instance for the spikes, and again I've changed the color. I've changed the exponent. So if you look, this exponent, if I lower this, you see that it becomes more and more filled in, so less opaque in the center. And the higher I get, it starts to push that edge to just a fresnel. So I'm going to do somewhere in the middle so you can kind of see the spikes. And the reflection, this kind of does a similar thing. They're almost like inverses of each other. You can go look that up for yourself. But anyway, that's the base idea there. So then when you put this all together, I'm going to go back up and run this. So here is our green. And then when I run it, begin play kicks off. It generates all of these spikes. The rotation starts turning the actor, and you get this really cool effect. So that's pretty much how you do it. I hope you guys enjoy this type of content. I really enjoy doing it. And if you like this and I've helped you out, please consider subscribing for more videos just like this. Thanks again. Have a safe day and a great day. Talk to you later. Bye.